Hi, everyone. Thank you for joining our webinar today. This is Elise Frida. I lead the growth team here at Yhat. Sorry about that. And today we're going to be giving you a live product demo of Rodeo, Bandit, and ScienceOps. As I mentioned, my name is Elise. I lead the growth team here, and I'm just going to do a brief overview sort of who we are, our three products that I mentioned, and then I'm going to hand it over to Colin, who leads our product management team, and he's going to give a demo of both Rodeo and Bandit. Bandit's a new product. Some of you who follow the blog might have seen the announcement about it. And then after that, Colin is going to hand it over to Greg. Greg's one of our founders, along with Austin, and also our CTO. And Greg is going to walk through a demo of our flagship product, ScienceOps. So if you're not familiar with any of our products, that's perfectly fine. I'm going to give a quick overview, and then I'll hand it off for the more technical details. And just a few housekeeping things. For everyone who's in the webinar, I'll be sending this out, the recording, probably late afternoon today or maybe tomorrow morning. It'll be published on YouTube, and I'll also include links to download Rodeo if you don't already have it, and to sign up for a beta or a demo of ScienceOps. And one last thing, there's also a chat. I have that on moderated, so feel free to send any questions. We'll save about probably 5 or 10 minutes at the end to go over any questions that you have. And otherwise, this should wrap up by around 2:30 Eastern time. So again, thanks for joining, and without further ado, for those of you who maybe are a little less familiar with us, we organize and equip teams to adopt and use data science. You might have come across a lot of you I saw that came and follow our blog. If you haven't already checked that out, please do. We publish 2 or 3 times a week on everything that's happening in data science, machine learning, engineering, really any of those topics. A lot of you might also know us from Rodeo, which is our IDE for Python, so a place to actually get into data analysis. We also have active and open source projects on GitHub. Follow us on Twitter. One example is ggplot. Or you might know us from our products, Bandit and ScienceOps. So to get into what those products are, this is the one that Colin will cover first, so I'll just give it a really brief mention. But Rodeo is our Python IDE for data science. So it's a desktop app that you can download. It's totally free. It's open source. We'd love you to contribute if you're interested. It's available for Mac, Windows, and Linux, and it's been around for a couple of years now, but went through super intensive development in the past, say, less than a year. So if you had an old version, we'd love for you to download it, give us any feedback, and again, totally free. And it's similar, if you've used RStudio, it's similar to that feel. Our newest product that we've added to the suite is Bandit, and that is a central hub for data science teams. So Rodeo you use totally on your own, although teams can, of course, use it. Bandit is a place that you compile and, I guess, centralize all of your work. So it's a place where you can automate and run your jobs, provision remote resources, and one thing that people sometimes think is that it's just Python, since Rodeo is, but it actually works for both R and Python scripts or jobs. And that product can be on-premise or hosted, but Colin will dig into those details in just a few moments. And then our final product, which is actually our flagship, our first product, for those of you who have known Yhat for the past 3 or 4 years, is ScienceOps. And this is just one screenshot of what it can do, but it is a production platform for model deployment. And it also works for R and Python. So once you've written your predictive algorithms, it allows you to embed them into web or mobile apps without any recoding. And then, of course, to manage them in their lives after, not just to deploy them, tracking, auditing, all those kinds of things. And that is also on-premise or hosted. So with that very brief introduction, I'm going to hand it over to Colin. And here we go.
Thanks, Elise. Hello, everyone. Thanks for joining us today. Rather than just show you guys what our products do, we're going to do something that involves our products, but is hopefully a little bit more fun, or maybe even remotely scientific. So the use case, what we're going to do today is we have a great data set with, I think, 1.5 million reviews of beer. So all sorts of beers brewed in from around the world in different regions, different breweries, reviewed by random individuals on the internet. And our goal is to take that data, manipulate it into some sort of matrices that we can then use as a recommender for other beers. So if you think about common recommenders you see online, Pandora is a classic one. Amazon says even more explicit of users who bought this also like this, which is another way of saying people who have looked at the same items you have, or have been searching in the same regions, have also searched in these other regions and maybe even purchased these other goods. So that's the high level goal of what we're trying to build, is an algorithm that can recommend beers to people. So we're going to first start in Rodeo. We're going to kind of just poke around in our data set, see what we've got there. We'll eventually build out an algorithm that I'm going to commit into a Git repository. We'll then integrate that into Bandit, where I will show you how we can use it as a system of record, a way to track our models over time, distribute insights about our beer data set and our recommender. And then once we've done that, the last thing we're going to do is take that recommender algorithm we've developed, wrap it in some ScienceOps specific code, and then deploy it to ScienceOps, where we'll create a dedicated REST API endpoint for it. And then the last thing we'll do is actually show you an app that you can use to get recommendations for beers. So enough talking, let's actually check out our data set. So I'm going to first launch Rodeo here, which, if you don't know, it's our open source Python IDE. It runs on Mac, Linux, Windows. Looks a lot like our studio, but it's just same thing. MATLAB, lots of SAS editors. It's just a pane-based way to visualize and to manipulate data. So with that said, our model, we're not going to do anything too complicated or crazy. So I'll outline first. Well, first we're going to import pandas, NumPy, and then the algorithm that we're going to use to recommend models is going to be the cosine similarity algorithm that scikit-learn has. Cosine similarity, from a very high level, basically looks at, say we have 10,000 different items that we can interpret as vectors. Cosine similarity basically looks at the distance across those 10,000 vectors, sorts that list, or rather returns the distance from each of those items, and then we can use that sorted list of distances to assume which items are most like each other based upon their proximity to other items. So that we'll dig into that more in a minute. So I'll start by executing this first block of code I've got highlighted here. We're going to read in our data set. You can see the code executing. I've got my terminal over here on the right. Downloading this data from S3. It's a pretty big file. It's about 120 megabytes or something, 1.5 million odd rows. And let's just take a quick look at what we've got here in our data set. So just doing a df.head in pandas, we can look at this first row right here. And you can see we have brewery ID, the brewery name, so the time that the review was written. So each of these rows represents a review of a beer. The overall review, then we have the review of the aroma of the beer. Oops. The review of the appearance. So if you liked how it looked, most beers in my experience are shades of brown, but maybe there's some preference to that. Then the name of the reviewer, the style of the beer, review palette, review taste, the beer name, and then the alcohol content. And then lastly, each beer has a unique ID. So pretty straightforward data set. And one of the things that I'll save us the trouble, many beer names come from Europe. Here's lots of breweries in Germany, Austria, and all of that. And many of the characters that are used in beers, like an umlaut and over a U, things like that, some of our plotting libraries find them disagreeable. So I'm going to run these lines 23 through 27. What that's just going to do is iterate across our names of beers and breweries and ensure that we don't have any Unicode characters that our plotting libraries can't deal with. So the first thing we're going to do is look at the distribution of our reviews. So if we, for example, we have approximately, I think there's 50,000 beers in this data set. To really build a somewhat robust recommender, we have to focus on the beers that have more than one review. If you think about it, how can we can't really compare with much confidence beers that have very, very few reviews because it's such little data to work with. What this chart that we just generated here shows you is on our y-axis we have this is like a CDF, or excuse me, a PDF. So on the y-axis we have like a the percentage of our data set that falls within these particular bins. And what we can see from this is the vast majority of the beers in our data set have fewer than 1 review, or than 5 reviews even. So what we're going to do in a second here is trim out any of the beers that have such a small number of reviews. Just to, one, it'll decrease the scope of our model, so it'll train faster for the sake of the webinar, but also we can have a higher degree of confidence. Before I do that, though, this is kind of where we begin to tie into Bandit. Since this data set of beer reviews is going to be updating as new users write new reviews, I want to see how our data set is changing over time. And in particular, I want to track a couple special values. So to do that, this is where we start to kind of foreshadow into what Bandit will help us with. I'm going to use the Bandit client to track these specific pieces of information that I think are important. So here you can see this is looking at the number of beers that had over 10, it shouldn't be votes, but rather reviews. So that'll just be a count. This is the number of reviews across the entire data set. Then we have the top beer. So this is the beer that is most reviewed by everyone. And then I kind of, just to get a feel for the distribution, we have like our 50th percentile, which will show us where the middle quantity of reviews across our entire data set of beers is. So I'll execute that code. And then this is what I was talking about earlier. We're going to trim out all the beers that are not in our 95th percentile. So we're only looking up at a relatively small number of the reviews. But this way, we're looking at the beers that are primarily the ones that have been reviewed the most. Now I've created a vector called top beers. We can take a peek at this. And what top beers is, these are the top beers that have been reviewed the most. So if you think about what does that actually mean, if you were to walk into a bar and ask someone, have you heard of 90-minute IPA or Two Hearted Ale? Based upon this very small bit of data here, the odds would be yes, these beers have been reviewed by over 2,000 or 3,000 people. So they're relatively common, and people drink them based upon the information we have here. So the next thing I'm going to do, oh, and the reason we're storing this top beers value is so that we can create a part of our recommender. If we want to create a recommendation for a unique beer, so a beer that is not commonly drank, we can eliminate this vector that we've created by just doing like a relatively simple join that I'll show you in a minute. So the next thing we're going to do is we're going to use the pivot table to translate our data into a wide table. So if you think about that, what that means, we want beers as our axes or our index. So you can see here the beer name, as well as the review profile name, because that's what we're going to use to create that cross section for our cosine similarity. Just doing some data munging, putting in zeros where we don't have reviews. And then here we go. This is where we're going to calculate our cosine similarity. So I'm going to create dis, which, like I said, this is the distances between all of these different beer review vectors. Let's just take a look at what that looks like. Oops. Oh, it's a NumPy array. Oh, here, I converted it into a data frame in the next line. So let's rerun dis.head. So here we can see every single beer now. So what we've done is created a table that has beer names on both the X and Y axes. So I have a visual of that in just a moment. So let's keep going. And let's create here. Now we create our matrix. So this is just a subset of our recommender matrix. But if you think about what these intersections mean, just looking at this dark black line in the middle, this is saying that 120-minute IPA is exactly perfectly recommending 120-minute IPA. So the darker the color here, the stronger the recommendation. Just looking at one of these like slightly darker patches, here we see that Two Below Winter Ale is a pretty similar beer or similarly reviewed beer as the 1554 Enlightened Black Ale. So this is, again, this is a very small subsection of the entire matrix we've created. But you can get a kind of feel for how this recommender is going to use this matrix to then produce recommendations based on other beers. So again, what is this doing? Here we're creating, this is some templating, dashboarding stuff for Bandit that we'll get into in a minute. What this is just going to do is create a dashboard when our job runs, containing the matrix you see here in the bottom right, and some of the other metadata that we've encoded as well. So line 95 all the way down to line 121. This is our recommender algorithm. So if we kind of walk through this, this function step by step, we're taking in products, which is basically a vector of beer names. So thinking about what we want to do, if I say I like 90-minute IPA, that would be an array with that name in it. And our objective is to return a vector of recommended beers based upon that input. We've also added flags for the number of recommendations we want to return. So if I want 5 recommended beers or 10. The probability, this is really just the strength of the recommendation or the distance from in our cosine similarity function. So if we want to return that. And then unique, this is what I was talking about earlier. So if we want to eliminate the top most commonly reviewed beers, we can pass in an indicator for true. And what that's going to do is eliminate those most reviewed beers so we get kind of uniquer ones or less frequently reviewed beers. So super straightforward, what we're doing here is we're looking at the distance matrix, just doing some summation of the rows. We're going to sort the values, reset the index. I'm just renaming the columns. And in case you've missed this, so basically what this is doing is saying if I put in the value of 120-minute IPA, looking at our chart here in the bottom right, we're going to look across this entire vector going to the right. So every single one of these different shades of kind of purplish, we're going to then sort those colors. Those colors are obviously assigned to another beer. We're going to sort them, and then we'll basically have a vector of dark to light, the darkest beer being the strongest recommended beer, and the lightest beer being the poorest recommender. Have just a couple simple, this is where we take in those function parameters from the top. And to give you a feel how this works, let's instantiate that. And then let's create a recommendation. So I'm going to run get sims for Sierra Nevada Pale Ale and a 60-minute IPA. And you can see here in the terminal on the right, you can see Sierra Nevada Celebration Ale, Stone IPA, 90-minute IPA, Sam Adams Boston Lager. So just a whole, again, this is our entire data set here, rank ordered relative to the 2 beers that we put in here. So it's pretty cool. This is our recommendation function. We can pass in any beer now and get a recommendation back. To turn that into an API, this is where we tie into ScienceOps. I'm going to create a special function using this Yhat model class. So if we step through lines 125 to 139, we're creating a beer recommender using the Yhat model class. I'm specifying the packages. This is what my model requires to execute. And then here is where we define the function where we're able to pass in the name of a beer in addition to several of our function flags, and we'll get back a list of recommended beers. I then put some configuration details on the bottom, but we're not going to focus on that for right now. At this point, I'm pretty happy with this script. I was playing around with this yesterday evening and tried some of the beers that I was recommended from this algorithm, and I gave it my personal stamp of approval. So we're going to get this all hooked up for running in production and on a schedule using Bandit. So to do that, I'm going to open my shell here on the left. We'll do a git status. I can see, let's diff my, okay, so I added a print statement. So let's commit that. We're going to push it up to our repository where we're keeping all of this code. Now, in order to track this, let's imagine that this beer recommender I have integrated into an application, and I want it to have the latest recommendations using the latest user reviews, using all the latest beer information we have. What Bandit's going to allow us to do is, one, set up this job to pull in the latest data set, build our recommendation matrix. But 2, it's going to also allow us to track the specific values that we looked at in our script so that every time this job runs, I can see in sort of a integrated manner how our data set is changing over time, and kind of begin to assess whether my recommender is doing a good job or not. So with that, I'm going to jump over to the Bandit UI. So for all of you who, as Elise mentioned, Bandit is our new product that's currently in beta. Definitely would love to hear if any of you are interested in trying it out. But again, the objective here is to take our script that we developed locally in Bandit, or excuse me, in Rodeo, and then now productionize it and get it ready to run on a schedule and start producing kind of a system of record for how this recommender is changing over time. So I'm going to start by creating a new project. We're going to use, so again, Bandit relies on Git or Git as a backend. So here I'm using our Yhat's GitHub server. I'm going to select the name of the repository that I want to pull in code from. So I'll do that, and you can see here, we're in my usernames, and then I've got, this is the name of our repo. So at this point, what I need to do is create a job. And what this job is going to be is it's going to be the kind of the recipe for what needs to occur on the Bandit server in order for this job to run. So I'm going to call this train and deploy beer recommender. The command that I'm going to run is just Python model and then rec.py. We can schedule it. For the sake of the demo, I'm not actually going to put this on a schedule so we can see it run right now. But we can set it up to run every day if we want to use, get the daily user data, hourly, etc. Next is I'm gonna specify the hardware that I need. So in this case, our data set is about 100 and I think it's 180 megabytes of in size. So I'll just use an X large here. We're basically going out and provisioning kind of on-demand hardware. So if I need 5 of these jobs to run concurrently, we can go spin those up on individual nodes and take them down when the job's complete. I can configure email to run, so if I want a notification that this job failed or that the job completed, I can use this little form right here. We also have options for using a client. So if you remember from my script, there's a Bandit client for Python and R. I can use that client to create custom emails. So if I want to include charts or graphs, HTML, and ship that out to members of my team, I can do all of that within the client as well. And then on the advanced side, I can peg it to a particular commit. So if I don't want this job to run from the latest version of my code, I can peg it to a specific commit and kind of lock it in. I can set timeouts, environment variables, and then lastly, if you're doing any sort of deep learning or have C bindings, custom stuff that isn't publicly available on the internet, we can put anything inside of these images or these Docker containers that are required or that the job requires it to run. So since our job is relatively simple, I'm just going to click create. So now we basically got this configuration all ready to go. And what I'll do is I'll click run. And what that is going to do is we basically grab all the code, the latest dependencies, we pull in the code from Git, configure the Docker environment where this is all going to run. You can see up here at the top, this is kind of our system of record. So I know that Python model / rec.py was run, Wednesday at 2:27. This is how long the job took to run. Here's the commit in Git that was used, as well as the Docker image. You can see down here at the bottom, we're starting to pull in all of our model requirements. So these are all Python packages. For those of you who are listening and wondering, does this all work for R? It does. It's basically the same, except it's R. So you can see here, we've now gotten to the point where we're running our recommender. So I'm downloading our latest data set from our data store, which in this case is, I believe it's S3. So all this data is going to pull down from S3 in just a moment. And while that's running, I'm going to go back to our results section and kind of give you a preview of what this is going to look like. So you can see here, I've filtered down. This is a table view of all of the different executions for this job. So I've only run this job once, but if you remember back from our script, I specified about 4 or 5 different values or metadata values to be tracked within this job execution. So what will happen over time is as I continue to commit to this project and say run it on a weekly basis, here we go. So I can track this is the number of reviews. So like I said, we've got 1.5 million beer reviews in our data set. The top most reviewed beer is the 90-minute IPA. Only 13,000 beers have been reviewed over 10 times. And if you think about how crazy, this is interesting, our 50th percentile is 3 reviews per beer. So we have a really, really sparsely reviewed data set. But now what we can do is look in at the output of our job. So one kind of theme to get from this is all of this information, all of these files that I've generated, all of this metadata, as well as this chart that I've streamed out here. This is a distribution of votes across, so 1-star all the way to 5-star reviews across our data set here. So most people are giving out, we have almost 500,000 4-star reviews. So definitely some considerations in how you weight a 4-star review. But anyway, so our metadata is all tracked here on the left. We've got all that information. Any plots or charts that I've made are accessible from here, so I can look at that matrix we were looking at in Rodeo and have that stored as part of this individual job execution. If I want, I can also rerun this, and what that'll do is it's going to grab the same git commit from our Git repository and execute the code in the same environment, so we're able to super easily replicate the results that we just created a moment ago. Just as a side note, so Bandit also has, in addition to this results tab here, where all of our job output is stored, we have a discussion section. Since I just imported this project, I don't have any discussion topics here, but if I was collaborating on building this recommender with a team of 3 or 4 or 5 data scientists, we could keep our discussion about how are we building our model, should we be using cosine similarity or some other vector comparison modeling technique. All of that information can be stored within this discussion, and then it's super easy to reference the results and the outputs, metadata, charts, etc. from our jobs because it's all being executed in the same place. So it's a really nice, simple way to kind of centralize both the execution of R and Python scripts, schedule them, and then also use it as a forum to discuss the kind of statistical merits of models that you may have trained or are working on developing. So with that, we're going to transition over to ScienceOps. Important to remember, if we think back to our script, I developed that Yhat model class, which you can see down here in the logs. I've this extracting model required packages, and then here are the packages that are required. This is all of us prepping to deploy that getSims function over to ScienceOps. So in case it's not already obvious, we did deploy a model in executing this script to ScienceOps. So we're going to now pivot over to that, which we can see right here. So this is ScienceOps. It is a platform for deploying and productionizing predictive models as REST API endpoints. So high level, again, is if I develop a model in R and I want my developer who's writing in .NET or Ruby or Salesforce, I can use one model and one API to integrate into all of those different applications. So with all that said, if we remember, we've deployed a beer recommender. So what we've got right here, this is an API that is backed by the model that we just created. So what does that actually mean? Well, if I pass in this JSON on the left, I'll get a prediction over here on the right. So here you can see if we recommend Sierra Nevada Pale Ale, we get Sam Adams, Sierra Nevada Celebration Ale, Stone IPA, Arrogant Bastard, and Hop Devil Ale. Seems reasonable. What's kind of fun too is if I pass in the flag, I believe it was unique, true. What this will do is it's going to eliminate some of the super popular reviewed beers. So if we hit execute, you'll notice for that same beer we were looking at earlier, we now get some that are like slightly less reviewed. Sam Adams Black Lager. It's hard to say if that's actually a good beer or not, but it's apparently slightly more obscure than what we were looking at previously. If we want to return the strength of the recommendation, we can add true to our request here. And now you can see this is the kind of cosine difference between the vector of Anchor Liberty Ale and Sierra Nevada Pale Ale. So kind of neat to be able to see, how close are these beers related to each other. So now that we have a REST API spun up, we can begin integrating it into an application. So with ScienceOps, we basically give you a whole bunch of code snippets that you can use. So here's a little Java code snippet that I could send to my developer and say, hey, put this in our beer app we're building, something like that. On the model management side, ScienceOps is really helpful with moving between different versions of our models. So if I, say I didn't like the version of the model that I just deployed, I can click redeploy on version 7. We'll roll back. There's no downtime, and any request that is, in transit during this redeployment of version 7 will be serviced by one of the models because they're both kept online until the redeployment is complete. Same thing goes with source code. So all the source code is tracked on the system. Versions of packages as well. So it's really a really nice way to kind of see how your code has changed over time. And then the last thing I'll show you, or second to last, all of the data that goes into and out of the system is tracked over time. So we can see, here's our latest beer recommendation, Sierra Nevada Pale Ale. Here is the output of the prediction. So at some point, probably after this model's been online for a week or so, we would want to begin to assess how good are these recommendations. It might be challenging in the case of recommending beer because we don't actually know if our users are going out and drinking. Presumably they are, but we don't know. So we would begin to kind of want to address that question though, of like, are our recommendations good? Are the changes between different model versions, are they getting worse? Are they getting better? This page basically provides a way to, one, ensure that your models aren't generating errors here, but two, get a feel for the recommendations and the values that your model is predicting on while it's actually running in production. And then the last thing I'll show you, ScienceOps is designed for production workflows. So if you're putting this into your app that's running online and being serviced by viewed by hundreds of thousands of people, it can handle that. Part of that means that anyone who's using the system is assigned a role. There's role-based permissions, lots of not super exciting stuff like that, but if you're doing things in production, they're helpful. Same thing goes with global model management. And then lastly, on the systems monitoring side, ScienceOps runs on a distributed system. So if one worker node goes down, the traffic will revert to the second one. You can see a snapshot here. We provide monitoring for the latest and greatest in DevOps monitoring tooling. And then kind of going back to the original thread of supporting open source. So we allow you to basically use any proprietary open source or maybe a package that you've developed, any sort of tools that you want, you can use within ScienceOps for productionizing predictive models. So the last thing I'll show you is we actually have a simple web app cooked up that's hooked up to the beer recommender. So if you go to beers.yhathq.com, you can enter in a beer, and it'll return back a list of 10 recommended beers with a sweet little UI and some beers ranked 1 through 10. So I encourage you, if you're interested, to check out this page. And with that, I think we're pretty much done.
Yeah, thanks, Colin. We've had a buzzing chat, so I think most of the questions have been answered in text. But feel free to shoot those over. For those of you who can't stay on for questions, thank you so much for joining. I'll send out the recording and have a great rest of the Wednesday. Otherwise, we'll take questions and stay on for a few minutes. Colin, one that we had, and I can answer this personally, was how Bandit compares to Elasticsearch. Do you have time for that now? Otherwise, we can follow up with Marcio with an email.
Well, Elasticsearch, in my understanding of it, is more of like a key value store. So you would use Elasticsearch for, I have a friend who works at the Times, and they use Elasticsearch to like find similar content, and it's a search methodology. So there aren't a lot of crossovers between Bandit and Elasticsearch.
Gotcha. All right, any other questions? Feel free to write them in. I don't see any so far. Just a bunch of thank yous. Thank you guys. Hope you enjoyed it. And check out the beer app.